All right. So today we're going to talk about graph of quadratic equations, something called discriminant. We're not actually graphing. We won't be graphing quadratic equation. By the way, when you graph it, what's it look like? It's going to look like a parabola. We're going to just sketch these. We're not going to actually graph them like the way we did it before. Do you remember how we graph parabolas, right? Using tables and things like that, right?
Yeah, cool.
But we're going to sketch it, and we're going to talk about something about the graph. Is that okay? And we're going to use this thing called discriminant. And let me tell you what it is. Okay, here you go. Write this down. When you have the quadratic equation y equals to ax squared plus bx plus c, of course you get a parabola. And the discriminant for this quadratic equation is b squared minus 4ac. It's this expression. And that should look kind of familiar. Anybody recognize that from somewhere? Okay, good. I'm glad. Angel, where have we seen this before? Yeah, it's from the quadratic formula. Where in the quadratic formula? Who remembers? Yes, sir. Simon? Inside the square root. So, you know that number inside the square root? That number is called discriminant. And we'll show you why this number is important to understand. Okay, so this is part of the quadratic formula. It's the number that's inside of the square root. Remember, x equals negative b, you know? Yeah? Okay, so it's the number is b squared minus 4ac, remember? Yeah, that number, okay? So write that down. Let's write it down and, oh wait, okay, and then move on to the next. Are we good? So before we talk about the discriminant and the quadratic equation and so forth, let's review something. You guys remember how to find x-intercept for a linear equation? For example, which form do we like in linear equation? Y equals to mx plus b. Remember slope-intercept form? We like this form. So for example, if I have this slope-intercept form, y equals to 2x plus 1. How do we find the x-intercept? Anybody remember? First of all, what is the y-intercept in this equation? Y equals to 2x plus 1. Chuck?
1.
1 is the y-intercept. We know where this line hits the y-axis, right? What is the slope of this? Yes, Dana? Slope is? Slope of this line is? 2. We know the slope and the y-intercept. That's easy. How do I then find the x-intercept? You can't just find the x-intercept from looking at the equation. You got to do something. Who remembers? Matthew? Yeah, you plug in 0 for y. You guys remember this? So it's a little review for the x-intercept. To find the x-intercept, you just simply plug in 0 for y. You guys remember? Why do we plug in 0 for y? Because any point on the x-axis must have what? 0 for y. Exactly. Think about it. If a point, right? Think about an order pair. Give me any order pair that has that is on the x-axis. Y has to be what? 0. Like 3 comma 2. Is that on the y-axis? No. 3 comma negative 2. Is that on the y-axis? What about 3 comma 0? Yeah, anything comma 0 is going to be on the y-axis. You guys remember? So to find the y-intercept, we plug in 0 for y. You guys remember that? So I want you to remember this because that's important. So go ahead then. Everybody tell me the everybody go ahead and do this. Tell me the x-intercept for this equation, linear equation. Okay? Because you will see it's really similar for the quadratic equation too to find the x-intercept. Go ahead, everybody figure this out. I'll wait. And since y-intercept is represented with this letter b, remember you guys, we plug for x-intercept. Which letter do we use for the x-intercept? A. So we plug in a comma 0, simply this, right? You guys remember this? So once you solve for a, that is the x-intercept. You guys remember that? So let's plug in a comma 0 to this. What do we get for the a? How about anybody not? How about, yes, Jason? Negative 1 over 2. Did you all get a for negative 1 over 2? Yeah. Okay, so what is our x-intercept then? Negative 1 over 2. The line goes through the x-axis at negative half, right? As an order pair, it will be negative half comma 0, right? That's why we plug in y equals to 0. You guys remember right here? You guys remember this, finding the x-intercept? It's simply a comma 0, right? I mean, for the x-intercept is a comma 0. Y-intercept is 0 comma b. You guys remember that? So the picture, if you were to graph it, there you go. We knew what it looks like. It's going to hit the x-intercept at negative half comma 0. I should have done this a little bit carefully because the unit, if this is whole 1 unit, this is a little bit too small. But anyway, let me do this actually. Let's fix that. Okay, so if this is 1, 2, 3, I should make this a little bit smaller. So let me erase this. Oops. Give me a sec. There's my line. It looks a little bit better now. Okay, so there's negative half, right? So it goes through negative half and 1, right? Any question? Okay, thank you. So there you go. Easy enough, right? The whole reason I did this is because, what do you think the process is for finding the x-intercept for quadratic equation? We plug in 0, 4. What do we do for the linear equation? For y equals 2x plus 1, what do we plug in for 0 to find the x-intercept? We plug in 0, 4, y, right? Because every point on the x-axis must have the y coordinate as 0. You guys remember this? So guess what we're going to do for the quadratic equations? Plug in 0, 4. Y again, it's the same thing. Because any points on, right, no matter quadratic or linear, right, the x-intercept must have y equals 0. Correct? Because x-intercept must be on the x-axis. Are you all following me? Does that make sense? That's what we're going to do. By the way, another name for x-intercept is called, anybody know what it's called? It starts with R. Oh. It's kind of like a tree. Because you could think of an x-intercept as ground. And wherever the graph hits the x-axis is called, yeah? The root. So another name for the x-intercept is called the root. Sometimes we'll refer to x-intercept as x-intercept or root. Okay? So please keep that in mind. So another name for it's like, but it's not really a root. It's where the ground and then the anyway. But root should be underneath, right? But anyway, that's what it's called. Okay? So where the graph hits the x-axis, right? The x-intercept. Another name for it is called the root. Okay? So by the way, you know how we had an equation y equals 2x plus 1? You know when I plug in 0 to this equation, these two equations they're both equations, right? But they're called related equation because, you know how we have this equation that gives us a line? When I plug in y equals 0, it's really similar to this, but it's not exactly like, right? You only have one variable, right? So these equations are called related. Okay? It's the same exact equation. Now when you plug in y equals 0, that equation is related. Okay? Because you'll see this on your homework. They say, oh, look at the related equation to this. Okay, that's all it means. Okay. All right, let's move on to the quadratic equations now. So now, of course, we get a quadratic equation, and when we graph this quadratic equation, we get a parabola. So if I want to find the roots for this quadratic equation, what do? Same thing for the linear equation. What do, Chuck? We plug in.
Wait, didn't you go to mx plus b first?
Oh no, we did that. So now we have a different equation. We have a different type. It's called a quadratic. We get a parabola, right? We get an x squared, x to the second power term. So we do the same thing to find the x-intercept. Guess what we're going to do? Plug in. Yeah, y equals 0. Same exact thing. So the related equation is going to be this, where you plug in y equals 0. That will get us the x-intercept, the roots, exactly, the x-intercept. And how many roots or x-intercepts do you think you're going to get for a parabola? You could get 2, can't you? Right? Remember parabola? Right? You're going to get 2. Is that the only way? So, okay, you get 2. Is that the only way to get x? Is that the, will you always get 2 x-intercept or 2 roots? How many people say yes? You're going to get always 2 roots for a parabola. In other words, whenever you graph a parabola, it'll hit the x-axis always twice on the x-axis. Is this always going to be true?
Yes.
How many people say yes? How many people say yes? When you graph a parabola, it'll always hit the x-axis twice.
Yeah.
How many say yes? How many say no? It's not necessarily true.
How many people didn't vote?
How many people didn't vote? How many people not so sure? Okay, I want you to discuss. What do you guys think? I'll wait. Is it always going to be 2 or is it different? Okay, so let me ask that question again. How many people again think that whenever we graph a parabola, you will always get 2 roots? Raise your hand. Still a lot less now, like 1 or 2. Okay, half a person. Okay. You guys are correct. So, no. What I'm saying is, you will not always get 2 roots. But somebody say, wait a minute, isn't this what we get? Like, you could have either parabola that opens upward, the smiley face, or downward. Can the parabola go sideways? No, that's not a. So we haven't talked about that. Don't worry about it. Parabola would always open upward or downward for us. Okay. When you hit Algebra 2, you will learn the one that goes sideways. But don't worry about that for now. So, isn't this the only possible? Somebody, okay, how do you say no? You will not always get 2. Okay, who thinks they know we won't get? Claire, when do we not get 2 roots? or two x-intercepts?
When the vertex
Uh-huh.
is above the y, the x in the x thing.
Okay, that's I like how you mentioned that. Okay, that's good. So when the vertex is above what?
The x line.
Okay, so when it's called x-axis. When the vertex is above the x-axis, will you? Then what are you saying? Then what would happen? What happens? How many roots do you get? If the vertex is above the x-axis, how many roots are you saying we get?
0.
We get no roots. How many people agree with Claire? When the vertex is above the x-axis, you get no root. Well, take a look at look at this one right here. Isn't this above? Isn't the vertex above the x-axis?
But it's going the wrong way.
So you gotta say it carefully. What you're describing then is what? Who can help Claire? What should she say? Yes, you will get no root if the vertex is above the x-axis, but what? But what is positive?
The points.
No. Okay, I want you to discuss with your group. What do you guys think? Come back. I'll come back. What do you guys think? She's saying it almost right. Okay, what do you think? So Claire, what do you think? Would you like to change your answer now? So
Not
when will
entirely.
yeah, not entirely, you're right. When will you not get no roots? When vertex is
It's
above the x-axis and
the a is positive.
when a is positive. Remember, a is the coefficient in front of the x squared. If a is positive, it opens upward, you get the smiley face. If a is negative, what do you get?
Down.
It opens downward, you get the negative face. So there are two possible ways. Simply, you will get no roots if a is positive and if the vertex is above, right? Above the x-axis. If the vertex is below the x-axis, guess what? A has to be negative in order to get no root. Does that make sense? You guys all? So there are two possible ways for that to get no roots, right? If the vertex is above the x-axis, opens upward, or if the vertex is below the x-axis and opens downward. Does that make sense? Okay. Okay. If you look at the first case, look, the vertex is below the x-axis, right? In order to get two roots, it must open upward or downward. I'm looking at this first case right here. If the vertex is below, in order to get two roots, what must A be? A has to be positive. It has to open upward. Isn't that right? Because if it opened downward, you wouldn't have any roots. In order to get two roots, if the vertex is above the x-axis, guess what? It has to open downwards, meaning A has to be negative. That's what these graphs are describing. Does that make sense? All right. Samuel says there should be another possible. What do you think? Wait. Yeah, what happens when the vertex is what, Jason? On the x-axis. Guess what happens? How many roots do you get if that's true? There's two. If the vertex is on the x-axis? Yeah, okay, I thought you said two. Here are the two cases. And for this case, no matter whether A is negative or positive, here you go, thank you. It doesn't matter, does it? Because if the vertex is on the x-axis, it will only have one root. One x-intercept, right? So that's the last case. So there are three really big, right, cases in terms of how many roots you get. You either get two roots, or you get no root, all right, or you get one root. By the way, when you get one root, it's called double root. We'll talk about why it's called double root later, but right now just know that because they may refer to you as double root. Doesn't mean there are two roots. Okay, does that make sense, guys? It's just when you get one root, it's called double root. Sometimes they will refer to that. We'll talk about why that's true, because you get two of the same roots for this case. Okay, so don't worry about it. Just that's what it's called. Okay, so you get one root, it's called double root. It does not mean that there are two roots. Okay, it means there are two of the same roots. That's why it's called double root. We'll talk about that later why that's true. But anyway, does this make sense? Do you see how we get three sort of, right, different ways? You could either get two roots, no root, or one root. Yes? Okay, very good. And we're going to talk about then why, or how do we know? So after today, when I give you a quadratic equation, you should be able to tell me whether we get one root, two roots, or no root. And you should be able to tell me whether or not the vertex is above the x-axis or below or on. On is easy. When would it be on the x-axis? If there's only one root, right? Because are there any other case? Can you have only can the vertex be on the x-axis and have two roots or no root? It's not possible, right? It has to have one root because that vertex is where the root is exactly. Okay, very good. Okay, let's go back to what we had, the related equation, right? What we're trying to do here is we're trying to figure out the x-intercept for this quadratic equation, correct? So when we plug in y equals to 0 here, how are we going to solve this equation then? Because once you solve the equation, that will tell you the x-intercepts, right? So we have the y equals to 2x plus b y equals to a x squared plus bx plus c. The related equation, when I plug in y equals 0, I get 0 equals to a x squared plus bx plus c. How am I going to solve this quadratic equation? Hint, hint. Anybody see how to solve that equation? 0 equals to ax squared plus bx plus c. Only few of you? Remember what we did on Friday. I want you to discuss with the group. How am I going to solve this equation? You should all know the solution for this. What is the solution? You should all know the solution, guys. Alright, so that of you are singing the song exactly right. It's that we solved this equation on Friday, and I even told you how to memorize this, right? So what are the solution? In other words, what's the x-intercepts when you solve this for this parabola? X equals to what? Negative b plus
minus square root.
there you go. Right? So I even wrote them separately, right? I get 2 of these, don't I? Right? So I can get maximum of 2 x-intercepts, right, guys? Does this make sense? All right, but is this true? Do we always get 2 roots? Think about it. We just said the answer is no. Sometimes you get none. Sometimes you get 1. What determines? Hold on. This is the key concept of the day. What determines then? We could possibly get 2 roots, right? What's going to tell us that we get either 2, 1, or no root? Look at the equation. Okay, I want you to think about it as a group. What do you guys think? What's going to determine we get how many roots we get? Okay, go ahead. Think about it. What's going to determine how many roots we're going to get from this? What do you guys think? Think about it. So, what determines how many solutions we get? One person see it?
I know it.
2 people see it. That's it after the discussion? How do we know? Okay, right now it looks like we get 2 solutions, but is this going to be always 2 solutions? When would you get no solution then? Michael?
When the A term is 0.
When the A term? What do you mean by A term?
The A.
No. When A is 0, you don't even get a parabola.
Yeah.
So A can't be 0 for a parabola. Okay, A has to be non-zero. When would you not get any x-intercepts? Jason.
When B equals to 0?
No, it's not just B. B could be 0. It's okay.
C equals.
Oh, but
No.
A equals to B.
I want you to think about what do we? Dana, what do we? Okay, here, Dana. Let's see. Dana, what do you think?
When the inside of the square root is 0.
Exactly. When the inside of the square is 0, then you get no solution.
Oh, no solution is when it's negative.
Yeah, when the number is. Remember this number inside the square root? What do we call this? We had a name for this.
Discriminant.
Discriminant. When discriminant is negative, guess what happens? Do you get any? You see the number inside the square root? When that's negative, guess what? Do you get any roots?
No.
No. When this is positive, how many solutions do you get? When the discriminant is positive, it's going to be, when the discriminant is positive, what? You get 2 solutions, right? Because it'll be, right? It'll get you 2 x-intercept. When it's negative, it's undefined, right? Can you have square root of a negative number? Guess what? How many solutions do you get then? None. When do you get then 1 solution, guys? When that discriminant is, think about it as a group. What do you guys think? When do you get 1 solution then? When the discriminant is, alright. Carolyn, what do you think?
When the b squared minus 4ac equals 0.
When the, what is that called?
Discriminant.
When the discriminant is 0. Libby, you said, what do you think? You get only 1 solution when that's 0. Yeah, if you do plus or minus 0, does it change the solution? Does it change the answer? No. If you could add 0 to anything, it's still the same right number. Does this make sense? You could add or subtract 0 to a number, it's the same number. Therefore, now that we know, this is what it means. Let's go back to, by the way, so what are the order pair for these? If we get 2 solutions, or 2 x-intercepts, or 2 roots, what are the actual order pair for these? It's an order pair, right? So if the point is on the x-axis, what has to be 0 again? What are the order pair for these points if it is twice on the x-axis? What do you know about the y coordinate? It's 0, right? What about the x coordinate? What's the x coordinate for these? Yeah, it's this thing, negative b plus or minus square root of b squared minus 4ac over 2a. You get two roots like this. Aren't these the two x-intercepts that we get? That's what we just talked about. Does that make sense? Yeah? Y is going to be 0 because it's going to be on the x-axis, and we know how to solve this equation, right? The x-coordinates we get is quadratic formula tells us what that x-coordinate is. Does that make sense?
Yeah.
Do you see how it kind of puts everything we learned together in one sort of section, right? It kind of puts everything together, and everything kind of works out. All right, let's look at this. So when we get this kind of picture, where we get two solutions, what can you tell me about the discriminant, b squared minus 4ac? By the way, the discriminant is not square rooted. It's just the thing inside a square root. Okay, please don't, if I ask for the discriminant, do not put square roots on it. Does that make sense? It's the number inside a square root. That's what discriminant is. So if you square root it, they're not going to get full credit. Does that make sense? So if I have this picture where you get two solutions, what can you tell me about the discriminant? The discriminant must have been positive. So write that down underneath your graph. What about this? If you get no solution, the discriminant must have been, Michael?
Wait, 0?
No, when it's 0, that's not. When do you get no solution? That's when the square root of some. Can you have a square root of a negative number? No.
No.
Guess what? So Michael, when you get no solution, the discriminant must be negative. And lastly, if you get just one solution where the vertex is on the x-axis, the discriminant must be yeah. If this is when what, Michael? When discriminant is? When what can you add to a number that doesn't change the value?
It's 0.
0. So when the discriminant is 0, right? The plus or minus really doesn't do much. That's why we get only one solution here.
What was the second?
The second one is when you get no solution, right? That means the discriminant must be negative, right? You cannot have square root of a negative number, remember? Does that make sense? Right? So do you see what discriminant tells us? By looking at the value of b squared minus 4ac, it tells me, without doing any of the graph, right, graphing, I could tell whether or not I get two solutions, 1 or 0. Does that make sense? Okay, on your homework tonight, that's what they're going to ask you. They're going to give you a quadratic equation. They will say how many solutions, how many roots would it have? Which means how many x-intercept does it have? Do you have to graph them? No, isn't this nice? Without graphing them, all you have to do is figure out what b squared minus 4ac is. And if b squared minus 4ac becomes positive, you know that there are two solutions. If b squared minus 4ac is negative, you know that there are 0 roots. No x-intercepts, right? If b squared minus 4ac is 0, guess what? There is exactly one root, and that root, that's where the vertex is. Does that make sense? Okay. So they're going to ask you simple questions like that. Okay. Does that make sense? Well, let's do something where they get a little bit more interesting than that. They ask you that and something else. Okay, so let's move on to the example then. Okay, so these are all discriminants, right? If this discriminant is positive, again, how many solutions? 2. If discriminant is negative, no roots, right? If discriminant is positive, you get 2 roots. Discriminant is negative, no roots, and discriminant goes to 0, you get 1 root. Let's do an example, and let's see how they get kind of creative, other than like telling them how many solutions you get. Okay, here we go. Okay, take a look at example 1. This is the kind of question you will see tonight. It says find the value of the discriminant. Okay, we know how to do that, right? What is the discriminant again? b squared minus 4ac. It's part of the quadratic formula, so you don't have to memorize it. It's part of it. Tell how many real number roots, or what's another name for roots again? X-intercept. How many x-intercepts does it have? X-intercept. X-axis is the actual line. X-intercept is where the line hits where the graph hits the x-axis. Okay, so it says how many real. If they say this is really simple, right? Now, do you see how they get? Let's take a look at how they get creative. Okay. Not only that, they ask you this, and whether its vertex lies above, below, or on the x-axis. That's how they get creative. It turns out it's not that hard to. All you have to do is do a little sketch. If you do a sketch, you will see where the vertex lies. Because if you know how many solutions it has and what other determines whether it be above or below or on. A. If A is negative or positive, clear is correct. Does that make sense? So you could have two solutions. If A is positive, in other words, if the graph opens upward, if you get a smiley face, where would the vertex be? If you have two solutions and A is positive, the vertex will be where? Above, below, or on the x-axis? It's got to be below. Does that make sense? So you do a little sketch. If you have two solutions, if A is negative, in other words, if the parabola opens downward, you get a sad face, where would the vertex be?
Above.
It'll be above. Do you see what we're saying? So that's how they get a little bit creative here. But it's not that hard. You just have to do a little sketch. Do you understand what we're saying? All right. So let's do the first example. We have an example, y equals to 4x squared plus 4x plus 1. And do we have to graph this like last time where we have 5 points and find the vertex and all that? No, that's not what they're asking. All they want is what? How many solutions it has, and whether or not the vertex is above or below the x-axis or on the x-axis. All right, so what do we do first? Step 1, find the what?
X-intercept.
Yeah, how do I find the x-intercept?
Plug in 0, 0.
Do we need to find the x-intercept? Is that what they're telling us? No, you don't have to. I mean, you can by using the quadratic formula, right? But if they ask you that, you could do that. But all they want is, again, how many solutions does it have and whether or not the vertex is above, below, or on. So you don't have to find that at all. But what do we need to find? Look at, yes, the discriminant, right? You need to find what A is, what B is, and what C is, and find the discriminant. That will tell you how many solutions you would get. And do we know whether A is positive or negative?
Yes.
Yeah, what is the A in this case?
4.
4, so it's positive, right?
Yeah.
So let's write this down. A is 4, B is 4 again, C is 1. Do you see why I circle A? Because I want to know whether or not A is positive or negative. They will tell me whether or not the vertex will be on, below, or above the x-axis. Does that make sense? So go ahead, everybody find the discriminant. I'll wait for you. It's b squared minus 4ac, right? When you plug it in, do you think you should use parentheses?
Yes.
Yes. Go ahead, everybody try. I'll wait. What do you get? So, when you do this, how many people got 0 as the discriminant? Very good. All right, so raise your hand. I want 100% participation. Raise your hand if you think we're going to get 2 solutions from this. How about no solution? I shouldn't say solution. How many people say we get 2 roots? How many say we think we're going to get 0 root? How many say we're going to get 1 root? Yeah, exactly right. It's because, right, you get 0 as your discriminant, correct? You could add or subtract 0 to a number, it's the same number. So therefore, now here's the critical question. You know how he says think critically? Will the vertex be on, above, or below the x-axis? On. Okay, that's easy, right? It's got to be on, right? Does that make sense? Let's move this up a little bit. Okay, who can tell me why the vertex will be on the x-axis? Why do we get only 1? Why do we get 1? I mean, why is the vertex going to be? Why would the vertex be on the x-axis? Yes. Yeah, because discriminant is 0. How many roots are you going to get? 1. And therefore, if you're going to get 1 root, only possible way for that to happen is if the vertex is on the x-axis, and that's the only one vertex. And that's the only one x-intercept. Does that make sense? All right, let's do the same one for B. Yeah. Y equals to 2x squared minus 3x plus 5. Tell me the discriminant. Tell me how many roots you're going to get. And tell me whether or not vertex will be on, above, or below. Okay. Oh, by the way, I forgot to do a little sketch on this one. Isn't that the sketch I get, right? Right, the A is positive, right? The vertex has to be on the x-axis. Therefore, you're going to get a new one vertex, okay? All right. Do a little sketch. That's how you could tell, okay? Do you see how we get that sketch, right? In order for this to happen, right, you only get one x-intercept root, right? And therefore, it has to be the vertex has to be on the x-axis. Who's got A, B, C for B here? How about yes, Aaron? Yes. Good. Who could tell me again? I circled the A because A is going to tell me whether it be above, below, or on. All right. Who could tell me the discriminant? Bella, what did you get for your discriminant? Negative? You got negative? What? 31. Is that right? Good. Yeah. If the discriminant is negative and your A is positive, right? What would your sketch be? Will the parabola go upward or downward?
Upward.
Upward, right? Guys, listen. And will then the vertex be above or below if it has no roots? Yeah, look, isn't this the picture you get? Do a little sketch here. Parabola opens upward. There's no solution. There's no root. Therefore, it's got to look something like this. Because if it's below it, you would have two roots, right? So what is the answer, guys? It'll be above the x-axis. Does this make sense? Can you do something like this for your homework tonight? Very good, guys. All right.